Hello, my amazing students. This is Mrs. A, and we are doing 8.4, which is solving rational equations. Now, the very first part of this, they're asking you to recognize the difference between a rational expression and a rational equation. Rational equations have equal signs, and then something on the other side that it's equal to. So, the very first thing they're asking us to do is look to see if this is an equation or an expression. Since it has an equal sign, it's an equation. The cool thing about equations is that we can use all of our equation properties, which one of them is the multiplication property of equality, which says that we can multiply both sides by the same non-zero number. And with equations, we choose to make that the least common denominator. So when I look at this, I have a least common denominator. The 3 goes into the 6. So I'm just looking at the least common denominator between a 6 and a 4, which is a 12. So now instead of getting a least common denominator of 12, I will multiply both the left and the right sides by 12. And I'm just going to write a 12 over 1. And over here, a 12 over 1. So that I can keep in mind that the 12 is going to the numerator. So now this 12 is going to cancel the 3. When I distribute this across to both of these, the 12 will cancel the 3, leaving a 4. So I wind up with 4 times 3q plus 2, and then minus the 12 will cancel the 6 with the 2, so minus 2 times q, excuse me. And then lastly, on the other side of the equal sign, the 12 and the 4 will cancel, leaving a 3, and we get 3 times 3 on the end, which is going to be 9. Okay, so notice the whole purpose behind multiplying through by least common denominator is that now I no longer have rational expressions at all. I have a regular equation, and this one happens to turn into a linear equation, not a quadratic. So when I go ahead and simplify this, I'm going to get 12q plus 8 minus 2q equals 9. Okay, so I've got a 12q and a minus 2q, leaving me altogether with a 10q. I'll put it up here. Okay, and then I'm going to subtract an 8 from both sides, and I end up with a 10q is 1, or q is 1/10. Since it's linear, I expect one solution, and q is 1/10 is the answer to this one. So q is 1/10. We were able to solve because it was an equation. Now, if we have an expression, we can only simplify, but an equation we can solve. Okay, so now the next one we're going to do is we're looking at this to see, is it an equation or is it an expression? Now, if you notice, this one is the first part of the one that we just did, okay? But it doesn't have an equal sign, so it is an expression. Therefore, we cannot multiply through by anything. We can only get a common denominator. In this case, we don't have something else over there, so our common denominator on this one is 6. So we're going to multiply this side, this expression, by 1 in the form of 2 over 2, like we did in 8.2. And now we're going to distribute. 2 times 3q is 6q. 2 times 2 is 4. 2 times 3 on the bottom is 6 minus 9 over 6. Since I have everything over 6, I can just go ahead and perform the subtraction on the numerator. We get 6q plus 4 minus 9, or 6q minus 5 all over 6. Okay, so let me see here. That is not a 9. That's why it's not right. I'm making my Q's look like 9s. That is a Q. So this right here is a Q. Since this is a Q, we've got 6Q and a minus Q. That's why my answer was not matching. So that is a 5Q plus 4. Okay, so my Q is looking like a 9, and it caused me an error. So 6Q minus Q is 5Q. 4 is up there, so 5Q plus 4 over 6 is the correct simplified answer. Sorry for that confusion. I will try to make my Q's a little bit more deliberately. The problem is I'm looking at the board from the side, and it's hard to see things a little bit. So this one, of course, is an equation, and since it's an equation, we can multiply through by a least common denominator. The least common denominator on this one is going to be 4x, okay, 4x. So we're going to multiply the entire equation by 4x. Now, because of space, I'm just going to write 4x once, and I'm going to multiply this by 4x, and this by 4x, and this by 4x, because every single term on each side gets multiplied by 4x, the least common denominator. Now, when I multiply 5 over x times 4x, I end up canceling out the x's and getting a 20. When I multiply 2 times 4x, I get a minus 8x. When I multiply x over 4 times 4x, the 4's will cancel, and I get an x squared. This one is quadratic because of the x squared. I should get 2 solutions. But this is not in a good form for me. I need to get everything on one side and a 0 on the other. Now notice this side has a positive x squared. If I pulled that x squared over to the left, then I'm going to end up factoring out a negative, so I'm not going to do that. I'm going to push everything over to that side and stick the 0. Okay, so basically I've got, here's my equal sign, x squared, and then as the negative 8x comes over, it becomes a positive 8x. As the 20 comes over, it becomes a negative 20. My 0's over here. But, you know, I'm a little OCD, so I'm going to take my little 0, I'm going to stick it on the end because that's where I like it. Okay, so now I need to factor this. I'm looking for a product of 20, but a difference of 8. So I'm going to choose 10 and 2, and my factors will be x plus 10, x minus 2, is 0. Okay, so when I solve this equation, x plus 10, x minus 2, I FOIL it, I do get my equation. When I solve it, I get a negative 10 and a 2. So negative 10 and a 2 are my 2 solutions. And if I go back up and plug in a negative 10, I get 5 over negative 10, which is negative 1/2, minus 2. So negative 1/2 minus 2 is equal to negative 10 over 4. And negative 10 over 4 is negative 2.5. And that's what I get on this side. Okay, likewise, if I plug in the 2, I get 5/2, which is 2.5, take away 2. Should be a half, okay? And then the 2 over here is 2 over 4, which is a half, and it works. Both of these solutions, negative 10 and 2, work when you plug them back into the rational equation. Okay, the next one that we're going to do is another equation that we're going to solve. And this one is very nice because we already know what the LCD is. M minus 5, this has just got a 1 underneath, so we don't have to worry about it. So we're going to multiply both sides by the LCD, which is m minus 5, and we're just going to stick a 1. Now we're doing this on both sides, so m minus 5 all the way across both sides. It's just because of space that I'm just putting it on one side, but I'm distributing everything with m minus 5. So m minus 5 times 9 is 9 times m minus 5 plus, and then 5 over m minus 5 times m minus 5. The m minus 5s will cancel, leaving me with a 5 equals, and here, this one times the m minus 5, the m minus 5s will cancel, leaving me with an m. Okay, now my goal, and what I should always see happening, is that my rational equation completely becomes without fractions when I multiply through by the least common denominator. If it doesn't, I've made an error. Either I chose the wrong least common denominator or I did something wrong in my multiplication. Every single term, even the ones that don't have a denominator, are multiplied by the least common denominator. So now I'm going to distribute 9m minus 45 plus 5 is m, or 9m minus 40 is m. So now if I subtract the m from both sides, I get an 8m. And then I'm going to go ahead and add the 40 to both sides, so I get 8m is 40, and m is 5. Oopsie! M is 5 is my only solution. Notice that when I multiplied through by the m minus 5, I came up with a linear. There's no m squared in there. So I'm looking for one solution. My one solution was 5. Guess what 5 does? It makes my denominator go to 0. Therefore, even though I solved and got 5, I must cancel out the 5 and say no solution, because the only solution made the denominator go to 0. So I have to say no solution. Now suppose you had this problem on the test. I would like to see all of this work. In other words, I would like to see you multiplying every single term on both sides by the LCD, okay, to get this equation. I should see this equation on your paper, or its simplification. So I see you go through all the steps to get to m equals 5, but then you cross out m is equal to 5 because you realize that it is not a valid solution. Okay, so here we have another one. And we've got 1/2 minus 1 over k plus 1 is k plus 5 over 2k squared minus 2. So remember, we're going to factor every denominator to find out what our least common denominator is. If I pull out a 2, I get a k squared minus 1. If I factor the k squared minus 1, difference of two squares, I get a k plus 1, k minus 1. Okay, so now notice this denominator is already present in here, and this denominator is already present in here. So this right here is my LCD. Remember, you want to box and label your LCD, because sometimes that's partial credit right there, just getting the LCD. So now, because it's an equation, I will multiply through both sides by the LCD. Okay, now I don't even have room on this one to write down the LCD, but this is in the numerator, and I'm multiplying this by 1/2. Oops, I just erased that. So the 2 on the bottom and the 2 on the top are going to cancel, and I'm going to end with a k plus 1 times k minus 1 for this first term multiplied by this. So now the second term is going to be multiplied. I'm going to put a minus in the front for that minus. And then when I multiply 1 over k plus 1 times the LCD, the k plus 1 on the numerator and denominator will cancel. and I will get 2 times k minus 1. And then for the last one, the denominator is the least common denominator. I multiply through by the least common denominator, and I wind up with k plus 5. Okay, so notice no more rational expressions. So now I'm going to FOIL this together and get k squared. Since it's conjugates, my middle term will disappear, and I'll get k squared minus 1 minus 2k plus 2. I'm going to bring everything to the left because I do have a quadratic. So minus k minus 5 equals 0. Okay, so now I've got a little bit of room up here. I'm going to go ahead and erase my little LCD here symbol. That is my LCD. But now I'm going to simplify this down here, trying to do it on the same board so I don't get all confused. So I've got a k squared. Okay, so now I've got a minus 2k and a minus k. So that's going to be this one, and this one will be a minus 3k. Okay, so I've already taken care of those 3 things. So then I've got a minus 1, a positive 2, and a minus 5, which is going to give me a minus 4 equals 0. Okay, so now this can factor. It's going to factor as k minus 4, k plus 1 equals 0. Okay, so I was able to factor, and now I'm going to set each one of these. You see, these are my factors right here. I'm going to set each one of these equal to 0, and I'm going to get k is 4 and k is negative 1. So my answers are k is 4 and k is negative 1. So this is what I came up with when I solved. But can you see that I have a problem? 2 solutions as I expected. K is 4 and k is negative 1. But although k is 4 is a valid solution, what about k is negative 1? Doesn't it give me a problem right here? Okay, so k plus 1 is in the denominator. If I plug in a negative 1, I get a 0 in the denominator. Therefore, I only have one valid solution, and that is k is 4. Okay, so now I'm going to try to put another one on here because it takes me less time to process these videos if I don't stop them. So I'm going to try to keep moving. 3 over, now this is a negative 3, and I get a 10a squared plus 20a minus 80, okay, equals, and then I've got an a over 5a minus 10, and I'm going to go ahead and put parentheses because this is so crowded, plus 1 over, and 2a plus 8. Okay, so I have the problem all written down, and it's very crowded. But can I factor this denominator? I have to factor, remember, to build an LCD. So this denominator has a 10 in it, so I'm going to pull out a 10, and I'm going to get an a squared plus 2a minus 8. I'm going to further factor into a plus 4a minus 2. Okay, so that a plus 4a minus 2 will give me the 2a in the middle. And then when I factor this one, I've got a 5 times a minus 2. And I factor this one, I get a 2 times a plus 4. Okay, so all of my denominators are factored. So now let's build our LCD. Our LCD has got to have everything here, which is a 10 times a plus 4, a minus 2. Now this one is a 5 times a minus 2, but 5 is already inside of 10, and a minus 2 is already inside a minus 2. Okay, so this one is included, and then the 2 is also in the 10, and the a plus 4. So my LCD is this one denominator on the left. So that makes things very nice. Now, I'm going to multiply the whole thing through by this LCD. Okay, now notice this LCD is already the same thing that's on the bottom. So when I multiply the first term by the LCD, the denominator cancels with the LCD because they're the same thing, and I'm left with negative 3. Okay, so then I multiply this expression by the LCD, and I've got a 5 that's going to cancel the 10. This is on top, this is on bottom, so I'm going to wind up with a 2. The a minus 2 will cancel the a minus 2. This is on the top, that's on the bottom. So I'm going to be left with this a times this 2 times the a plus 4. Okay, so then I move on to the next term, which has got a plus in the front. And I've got this 2a plus 4 on the denominator. I'm multiplying by this on the numerator. So I'm still going to have the 2 on the bottom, the 10 on the top. I'm going to have a 5. Okay, the a plus 4 on the bottom, the a plus 4 on the top, I'm going to cancel. And then this a minus 2 is on the top. Wow, that's a lot of work, right? So then we're going to simplify to see if we can solve. Okay, so now I'm going to come right here. I'll make a little spot here. I'm going to get a different color so you can see, because my board is getting so crowded, but it is easier for me to get the big picture when it's all on one board. Okay, so, oops, I erased that. That's going to be a minus 2. There. Okay, I erased it. So now I'm going to come up here and say negative 3. So now I'm working in black so it stands out. Is equal to. Now this is going to be 2a times a is 2a squared. And 2a times 4 is 8a. And then 5 times a is 5a. And then 5 times negative 2 is a minus 10. Okay, so now I'm going to get everything on one side with a 0 on the other. So I'm just going to add a 3 to get my 0 on the other side, on this side, and add a 3. So that's going to wind up being 0 equals 2a squared. Okay, and then plus 13a, and then minus 7. Okay, so let's factor that on a different board so that we can see it. Okay, so we're going to have 2a squared plus 3a minus, 13a. That is a 13a, not a 3a. 13a minus 7, because that was an 8 and a 5. Okay, positive 8, positive 5a. All right, so now when I factor, that's equal to 0. So I'm going to have a 2a and an a. I'm going to have a 7 and a 1. I'm going to make this positive, this minus. And lo and behold, if I FOIL this together, do I get back here? And I do believe I do, because I go to 14, take away 1, and a negative 7. So these are my factors, and I wind up with a is positive 1/2, and a is negative 7. Okay, so let's go look at our original least common denominator. Okay, so my original least common denominator would not allow a to be 2 or negative 4. Okay, but when I look at what I got, I did not get a 2 or a -4. Therefore, these two are the correct solutions, and that is also what my answer key says. So I would solve them, I would circle them both. Okay, so now let's look. Let's recap this one because this one's really a long one. We wrote out the problem. We factored. We built our LCD, which is right here. We multiplied everything by the LCD to get this equation, which simplified to this equation, and this got really, really messy. So I wrote this again. Okay, so this was the resulting equation here, which we factored. We set equal to 0. We factored using our zero factor property and solved. So we have, let me see if we have another one here that we can work on. Yes, we do. Okay, so we're going to do a few more, and then we'll call it quits on this one here. Okay, so we're going to start with 18 over v plus 5 is equal to 3 over v. Okay, so again, we have an equation. So we look at both denominators, and the denominators are already prime. When the denominators are prime, the LCD will be the product of the two. So we're going to have v plus 5 times v as the denominator, or the least common denominator. So again, instead of putting them over the least common denominator, I'm going to multiply both parts by v times v plus 5 over 1. On the left and on the right. The only reason I'm only doing it on one side is because of the room on my little bitty boards here. So now I'm going to take this common denominator, multiply it by this term over here. The v plus 5s will cancel. I'll be left with 18v. On the right hand side, this multiplies and the v's cancel, and I'm left with 3 times v plus 5. Okay, so then when I simplify, I get 18v is equal to 3v plus 15, or now I want everything on one side. So if I subtract the 3v from both sides, I get a 15v on the left is equal to 15 on the right, or v equals 1. Okay, so if you take the time, v is equal to 1 is the solution. If you plug in a 1 here, you get 18 over 6. Well, that's 3. You plug in a 1 here, you get a 3 on that side as well. So the answer is v is equal to 1. And this was in the part that's just talking about proportions. When you have a rational expression set equal to a rational expression, instead of performing this method, you can always just cross multiply. When you cross multiply, guess what you get? 18v is equal to 3 times v plus 5. Can you see right here that this is what you get when you cross multiply? And the whole part about this cross multiplication is that it is a shortcut for multiplying through by the least common denominator. Okay, so let's do another one of those proportions. And this one is x plus 2 over 6 is equal to 3 plus x over 8. Okay, so this one, I'm going to use my proportion here, one rational expression equal to another. I'm going to cross multiply and get 8 times x plus 2 equals 6 times 3 plus x. So when I distribute, I get 8x plus 16 is equal to 18 plus 6x. If I get my x's on the left, I subtract a 6x and I subtract a 6x over here. So I'm going to get a 2x plus 16 is 18. If I subtract a 16 from both sides, then I get 2x is 2 which means that x is 1. X is 1 is my answer. And if I plug in a 1 here, I get 3/6, which is a half. If I plug in a 1 here, I get 4/8, which is a half. And a half is equal to a half. Therefore, the answer, x is 1, is correct. Okay, so we're almost there. So now we're going to solve an equation for another, or formula, solve a formula for a variable. And the first one we're going to do is t is n over little r minus big R, and we're going to solve it for the variable r. Okay, so this was in 8.4, solving a formula for a different variable. So if your boss gave you 50 of these problems, but on each one of them he didn't want t, he wanted r, you could turn the whole equation around and solve it for r. To do that, this one, since if I put a t, the t over 1, I have a proportion, I'm going to cross multiply. So I'm going to get t times r minus big R is n. The first thing you want to do is get whatever variable you're trying to solve for in the numerator. Okay, you can't solve for it if it's in the denominator. So I'm going to cross multiply to get my r, which is what I'm looking for, in the numerator. So I get t little r minus t big R equals n. I'm trying to solve for the little r. So I want to get the little r term by itself. So I'm going to I'm going to add the t big R to both sides. If I add it here and I add it there, I get n plus t big R, right? I'm just adding it to both sides, the tr to both sides. And now I want r, not tr, so I'm going to divide by t. So I'm going to divide this side by t, and I will get just r. And then I'm going to divide this whole side by t, and I didn't leave myself any room to do it. But the answer is going to be n plus t big R over t. And that is the correct answer for little r. So little r is n plus t big R all over t. So I've solved the equation for little r, so if I had 50 problems to do, that would save me a lot of work. Okay, so we have one more problem, and it is actually one that I worked in class for you, but I'm going to do it again because it's on this little review sheet. It's 1 over a plus 1 over b equals 1 over c. Okay, so I'm not even sure what that formula is for, but we're solving it for a. Okay, so I'm just going to put the one we're looking for there. So notice that our a and all of our other variables are down in the denominator. So I'm going to multiply through by an LCD. The LCD is A, B, C. That is the LCD. Okay, lots of letters there. A, B, C is the LCD. So now I'm going to multiply the whole thing on both sides by A, B, C over 1. Okay? 1 over A times ABC is going to cancel out the A and leave me with a BC. Then I have my plus sign. 1 over B times ABC. I'm going to cancel out my B's and leave AC. 1 over C times ABC. I'm going to cancel out my C's and leave AB. Okay, so I have no longer got a rational expression. I've got a nice little equation. I'm still trying to solve for A. Okay, since I'm trying to solve for A, wouldn't it be smart to get all of my A terms on one side? So I've got an A over here. I'm just going to go ahead and subtract an AC from this side and subtract an AC from the other side. Okay, so since that goes away, I've got BC equals AB minus AC. okay? But I'm trying to get to A. What if I factor A out? Okay, so I'm going to factor A out to the front, and I'm going to get BC is equal to A times B minus C. Okay, so I'm going to get a little bit bigger here. So I'm going to write that again. BC is equal to A times B minus C. So I got down to there. So now I'm trying to solve for A. That's the only A. If I divide by B minus C, divide this side by B minus C, then I wind up with A equals BC over B minus C. And there's my A. So that is the end of 8.4. And this is Mrs. A, and may God bless your day.